Hey everyone, it's Krista here, and we are at the rotational molding machine at the business I work at. Rotational molding is kind of fun, and we're going to probably have like all kinds of videos just about it. So I'll say a little bit, but then I'm going to kind of get to the meat of it. I mean, there's so much to do and say and cover that I haven't even sat down and thought how to organize. It's just that what I have to do right now today for production, the next things we're producing is one of my favorite things to do, and that's load a tool onto the arm. I'll pull you around. Over here. So this is the arm, and so that's the oven, and it's going to swallow the whole arm and make it hot. Now, this is the arm. So the arm could be anything. It could be everything with the electronics running the motor, the gears, the chain, all of it, or it could be literally just this 5-inch shaft. So this is the arm. This bit here spins, and we go about 4 RPM, 15 seconds per rotation. As the arm turns, these platters spin. It's got a brake on it, so this is a brake. So these spin. And as you can tell, it's almost balanced rotationally as far as the minor axis goes. It does have a little spot, and we'll deal with that. So I'm going to go ahead and put the brakes back on. So there's a 4-to-1 gearbox in here. It's actually 3.97 to 1. And so for every 4 turns of the arm, the platter or spider gets 1 360-degree revolution. Because of how this works, we get all areas of rotation in the mold covered. Okay, is that enough? All right, so we're changing the tools on the arm so I can change the production. This is a tool. This is one of the fuel tanks we mold. We call it the HM69 for hypermotard, and it has a capacity of, in theory, 6.9 gallons, but it is that's the volume of the outer surface, not its capacity. Its fluid capacity is 6.4. All right, so I don't know how much this tool weighs, and so like here's another part of physiology. That is a mold, or that is a tool, and of course civilized sections of the world will put a U in mold. Now, we don't need the engine hoist at its stronger setting, so we put it at the 500-pound setting so that we can get a better handle on the tool. All right, these are some of our J-bolts. Now, ultimately, we want this tool to be on its side. So we're going to see if we can man that with this. The whole goal of working with these heavy things is to actually not hurt yourself. I just realized I am not as prepared as I would be because I'm eating other shit. Um, Here's- Fine, let's try that. Let's see what happens. Okay. How would I grab it with two? It's tricky dealing with things with grouping centers and then start going very quickly. You don't have much say and you hurt. So it's best to triangulate with three straps. Plus we've got all these insert screws and we don't want to screw any of those up. All right, so let's put a strap. Here. I really don't want to bend that one fastener. So if I'm not careful, I'm just going to bend these screws and this one's already pretty bent. I have to take a mold part anyway to change its date so we can fix anything we screw up. Now we're going to use two more straps so we triangulate. That's not good. Can we put one up here? Oops. Okay. Now I'm going to redo this one over here. Because if you keep tightening, you're going to load up your ratchet. Okay. There. Center of gravity messing with us. This is kind of always about fun games of physics. What exactly pretty sure how to pull this one off. Typically, I do a little bit better job with this. Like I remember the last few times, I was like, oh, cool, I guess just perfect. Look, now we got this one down. Now you want to make sure you don't just open the damn strap because that would be sadness. And we don't have enough rotation. Okay. So you can't quite tell, but I didn't have enough wound up on this. So it's actually not ratcheting at all. And I'm holding up its weight with the strap. There we go. That's close enough we can manage. Okay, so now let me show this. We get it to the arm. So we've got a track on the floor, so the wheels have to avoid the track. And then just like with an engine, if you're moving something heavy, you don't play with the frame, you actually move the heavy thing as you move, as you walk. So we're supporting the engine occasionally, or the engine's mold. But if you need to really move, it'll act independent. Now we need to turn it down. Jog this a little bit. Right. Now I keep looking back because the computer is down there and your eyeballs are there. So we're going to raise the tool a little while, and then before it gets hot, we're going to help it. Okay. You play with these things enough and you kind of get used to the tricks it takes to get things not come up. The track on the floor really does not help. Now, if I had a forklift or a crane, I could have picked this up flat. I could have had it to the spider level, and I could have just dropped it on top and slid it around. Dropping it on top and sliding it around is the next step. All right, this those clamps are neat. So let's drag you closer. All right, so most of the technology I'm using are from the electrician world. It's Superstrut is the brand name, and so it's mostly half-inch hardware. This is a beam clamp. That's another beam clamp. It clamps onto a beam, but I use it to mount to the 90 angle. And then after you figured out kind of the tricks for each tool, you get to know what works. Okay, we got him on there. Now we don't have him on there. It's kind of binding a bit. I need to get another one on. You can sort of see the other side. The great thing about J-hooks is once you get to a certain amount of tightness, they won't let go of. So the spider is made of angle iron. Looks like it's it's 2 inch by 2 inch by quarter. And I got a crafty jig bolt for the well. So now what we're doing is we're making less of a gap than what the hook has. So we're limiting the travel along this track. All right, that's stuck to that. He won't come off. He's attached. No, he's not attached. What's my problem? Other than I have a problem. I need to get these bottom ones on. Get that out of here. All right, let's gently rotate the arm a little bit. We're going to do the top. All right. Except for we actually need to be a lot higher. Take this off. now. And if I can get this other one to convincingly stay hooked, we can actually rotate the arm further away, and then it'll stay attached for that to get it level. And then once it's level, we can dial in exactly where it's located by just sliding it around. We're not going to go a whole rotation because that would be really bad. Hopefully we can just rotate a little bit more, get the mold laying flat on the platter, then we can disconnect the straps, and then that will be great. There we go. They're all unloaded a little. You know, I just like physical problem solving. Honestly, you could call it mechanical engineering. And it's practical because it's here, you're watching it. And you get to be clever-ish. Right, we're not going to put that on the hoist because it doesn't belong to the hoist. Now let's get this out of the way. We'll run several months without changing the tools on the arm, just basically due to demand. Now take off the brake. What can you see? Okay, let's give you a little bit more specific view. We take off the brake, so now we have total freedom. And then, for some reason, I have perspiration. I wonder what it is. I'm just not as strong as I used to be. All right, so here's the game plan. I have 2 holes here, and I need them to be on the back side of this frame so I can run J-hooks through them. And I need this one to be on the left side of the frame so you can hook. So we need to go that way a little bit, we need to go that way a little bit. Hey, look, you're there. Isn't that cute? Maybe this will work. This is actually, I think, the weakest I've been. I'm changing these because I was always able to drag this tool around. All right, so now Now we're going to check balance. So I slid the entire tool that way. And it needs to go more. So it needs to pull down on that side. That is perfect primary balance away from you. More, now you look twisted. There we go. That's not as twisted. You can better appreciate how flat it is like that. Okay. So really well balanced top to bottom in the one dimension of that way. Now let's prove this way. It definitely needs to go that way, which we already know because these holes are not behind the ledge. I have completely rebuilt this arm. Everything about this arm has been fully disassembled, re-lubricated, not necessarily properly rebuilt, but I've inspected everything and it's good. And so a little cheat, I have these beam clamps set so that these bolts are right up against the edge. And these are also up against their edge. And actually you go a touch more that way. That's really close. And you don't need absolute perfection here, really close is good enough. Now on these aluminum parts, I like to have a good pad to distribute the load, so I use a square washer. I'm not sure we'll be able to do this trick. I just don't know if there's enough room. You can reach through, and sometimes you can feed it through the hole and drop it over, but it's too thick and there's a frame right behind it. So we have to unwind these completely and feed them through like you would think a J-hook needs to be fed through from the bottom hooked onto the frame. It tightens, it goes that way. This tool has made over 1,000 parts. I've estimated it has run about 1,200 tanks. And that's a lot. Each tank takes an hour to make minimum. You have 20 minutes in the oven, 20 minutes for cooling, and in mass production, then you have 20 minutes to get the old part or the part you just made out, prepare the inserts, and put it back together to run another run. This mold has 41 inserts. I do not know if it is even possible to do a 20-minute turn on this tool. My molding is very much specialty. It's custom molding just for minor tools. In normal production, you're competing against other rotational molders. So you're going to have as many tools on this arm as possible. And you're going to be making as many parts with each 20-minute bake that you can. That's how you maximize profit for your invested expense. To get more tools, you're going to make an oven that's bigger and you're going to have a bigger platter. This molding machine is called a 6-foot oven because the platter is 6 feet across. It was custom made by a manufacturer in LA region, Los Angeles, California. And the people who made this oven they did the best molding quality of any of our vendors we use. That's going to be. I use a gear wrench. And kind of the irony is that when you get a bad spot like this, it's loose for a turn and then you're stuck for half a turn. So in order to keep using these gearbox, I do run into a dime occasionally. A fun side note, maybe I'll bring you really close so you can kind of see better what's happening. Okay, our power cord is wrapped around the leg of the tripod. There we go. Sorry, you're on vomit cam. There you go. So this is the J-bolt. This is the super strut angle bracket. You can't get a J-bolt at your typical hardware store. You can order them on Rotomart has it. And then like we have a local bolt company. They're pretty amazing. They have those. We bought these from them. They're called Anderson Bolt. But they're here in Conyers and I don't think they'll sell to you. Then this is a beam clamp. And it's shadowed, it's still shadowed. Light. No, I don't have a light. I mean, that would just make too much sense. I have no idea what my cell phone is. Let's try this. Okay. Got my cell phone. I'm going to illuminate that clamp a little bit. Maybe that will help. There you go. You see the beam clamp. It has a 3/8 16 pitch hole threaded, and I have a 3/8 bolt, which has a 9/16 head. You'll hear a lot of people say it's a 9/16 bolt. No, that's the tool, not the bolt. So it has threads on both of these sides, and then there's a clamp on the far side. I don't know. We'll see if we can get you a better view. Do I have one laying around? This is a beam clamp. They make them bigger and smaller. The next size up, it looks like that could be a 1/2 inch. Yeah, that's a 1/2 inch screw because it's a 1/2 inch square. So the next size up has a 5/8 screw and it has 1/2 inch threaded holes. So it gives you pretty good technology for clamping onto a beam. And then you tighten it. So if you imagine this is upside down and this is clamped to a beam on your rafter, people will use all thread to suspend lighting from this, or all kinds of weird stuff. It's like an adult erector set. Okay, back to what we're doing. Let's see, we need to add more J-bolts. Originally, the other manufacturers will use C-clamps and just clamp tools to the arm. And I thought that was kind of sus to begin with. And then, so I decided to kind of use the think meat, and then I was like, oh, I could use the superstrut stuff because I had just used it on the natural gas piping and for the electrical stuff on the oven. Wow, it's hot in here. So I don't know if these J-bolts have a grade per se, but they're pretty low grade. I mean, sure, they're plenty strong, but they're soft-ish because sort of all this stuff needs to be a little bit bendy because nothing ever lines up perfectly. And I've noticed that if you don't use zinc washed nuts and instead use the black oxide ones, they will seize and break the threads. I've been using these zinc washed nuts for 2 years and they've been very good to me. This one's been threaded a little more than that last one we did. And so on here, you can or cannot see all these dimples. This is from when they just had C-clamps. And then I drilled these holes so I could have a positive fixture of the mold to the arm. I did have a mold come loose and fly off, and that was super scary. Thankfully, it didn't hit anybody and it didn't harm anything. And I was able to hit the E-stop fast enough, so it only went bang one time. But that was pretty scary. So since that happened, I've decided all of my molds will have at least 4 points of contact and 4 bolts. There's one of them I have an exception for. It's actually one of our lighter tools, and it's very awkward, but it has supremely secure mounting. I'm probably getting 30 foot-pounds of torque on those. All right, we've got the J-bolts tightened. Let's double check the other fasteners on these V-clamps. Assumptions. So these silly gear wrench things, this one's from the blue hardware store, and the other one's a gear wrench because I dropped the blue hardware store one and it exploded. The gear wrench one I've dropped once or twice, it's still alive. So kind of like a handy point is every time you pick up a wrench, play with it to see what it's doing. This is loosening. So we turn it over so we can get tightening. Now I know from habit that the 9/16 wrench tightens away from the jaw and my 3/4 inch wrench tightens towards the jaw. Oh, that's plenty tight. Okay. And then on the back is the square that you can just now see. That was probably fine, but that's why we come back and double check. That guy was pretty dang tight. But aluminum's soft, and we're driving our point in to the material every time we tighten it. Let's get a different angle. I could try harder, but that one's really on there. That's probably that's easily 30 foot-pounds. All right, so this mold is absolutely secured. Get you just out of rotation. All right, so when I talk about balance, you can see the chain right here. So we're going on another field trip. Find the power cord. Okay. Drag you back around. So that's the chain. So you can see there is a little bit of slack. That's about as tight as a human can reasonably get it. To get it that tight, I think, put a jack sideways and tried to spread. But then I wanted the alignment right, and that took a little bit of effort. So you can tell when you're balanced because of the effort it takes to push up and down while watching the chain. So I've done these two molds on this arm so many times. That's how I was able to just throw it on there, and literally our arm balance is almost perfect. So I'll show you the next part. We're going to turn the arm 90 degrees so that the spiders are up. I should have just hit run instead of jog, but oh well. Another dimension of balance. And when I let go, it's totally against the chain. And so it needs a little bit of force to fix it. This is a cast aluminum mold, and it actually weighs more than the billet aluminum larger tool we just lifted onto the arm. So way out here, that might be 10 pounds. So we need to rotate around 180 so that we can get the other lighter tool on this side, and we're going to add some weight. Actually, maybe before we add the weight again to get better balance, as you can see, it's so like a wheel, it is not balanced this way. So it's almost perfectly balanced with this axis straight up and down. But now we have two more axes to balance. We have to balance this way and this way. So I got one axis balanced perfectly. Now we have to do the other two. So this is like the wheel balance, where the part that ends up on top is the direction you need to put the weight on. And typically, I will take a marker and then just line up with a pivot and do that. So I know that's the axis I need to put the weight on with relation to the pivot. Now what I want to demonstrate is why what we care about is next. This is the variable frequency drive, VFD. And what this does is it takes the 60 hertz AC, three-phase, and it changes the frequency to the motor so you can change its speed. But it does all kinds of trickery with higher frequencies so that it still has power. So it doesn't just transmit a pure sine wave, it modulates the voltage going through the motor. There's all kinds of science and magic into these. These have come down in price in the last decade remarkably. This thing's like 150 bucks maybe. And so now we're going to change this display to current. And everyone's clear of the arm. And so watch its current. Actually, I need to take the brakes off too. There we go. So now we have an unbalance, and it accumulates depending on what phase the rotation of the spider is. But look, we're only, what, 0.2 of an amp right now. So our low was 2.6, our high is 2.8. That's not bad. And now we went to the frequency, so it's 39 hertz. 39.9. the VFD runs this 1.5 horsepower motor. At 208, it's rated for 5.3 amps at 1.5 horsepower. And you saw we're under 3 amps, so we're only pulling like 0.9 horsepower probably. So this is turning at, so what's its rating? RPM is 1725. If the VFD's at 60, it's 1725. We're at 2/3 of that, whatever RPM that is. This gearbox here is a 72-to-1 reducer. And then now we have further reduction of 1-to-4 via 1560 sprockets. What that means is that the arm is basically turning at 3.99 hertz, roughly. All right, now let's get you on the other side. And now, do you hear all that creaking? Something's loose. And you notice we tightened up this tool pretty well, but we didn't do anything for this one. So we are going to go through and tighten him before we go into production. In fact, why don't we do that now, because it's in our brains, and maybe we'll see something meaningful. I use a foot brake for, or foot pump for the air brakes, because I'm lazy like that. Okay. It's all the way tight. Sorry, the microphone rub was really loud. Well, that wasn't all the way tight. I think I need a 5. Yeah, okay. So one of those, oh yeah, that was definitely, that was probably our kicking. Yeah. All right, so that should be 3/4. And it goes to its job. And don't put much stock into that thing tightening. Those are fine pitch threads. But that might have been, maybe. I mean, see, we're getting a 1/4 turn on some of these, through all the heat cycles. Can you see? So this bolt right here is, I'm not sure which one, but one of these is a black oxide nut that broke, or that locked onto the threads. It galled onto the threads and it broke the J bolt. So now we just use it as a plain old bolt. That was pretty tight. That was tight. All right, so maybe it won't creak now. There, right in the face. So let's rotate a little more and get it vertical again. So the air brake is off, and I want it to be balanced enough so that when I release the brake, it doesn't spin on me. So it needs to be along this line. I think I can put a weight here. That might be a bit much there. That might work right there. So actually I'm able to kind of hold everything in place pretty well. Let's come up from behind here. You can't see what I'm doing. So typically what I do is just something to get it started, and then I'll figure out a second clamp. Once I have it where it belongs, close enough, let's get vertical. That's pretty good. Because basically it's gonna be sort of close anyway as far as like this. Remember, it was just a little bit, trying to slip. That's pretty good right there. Let's add another bolt somehow. So now a great way to add another bolt is to make it flat so we're not fighting gravity. Or flat-ish. And I'm always ready to just absolutely jump out of the way. Really? Let's move this to one hole, and then we can do 2 bolts across the middle frame. Sounds like a plan. Let's do this. Oh, okay, that's interesting. Maybe we need to go a little bit. Well, that just sucks. There's no. I could just clamp it in the middle of that. And I don't like that idea. So we just need to keep driving. Sorry, Rachel. Can you even see what I'm doing? You can't. So I'm trying to get this. See how this J hook is here? I'm trying to get that one across here too, but it's got this cross brace there, and it's totally in the way. Can we just undo this more? Oh, my arms are about done. Now, it's mildly abusive to have these not straight, but that's good enough. There we go. It is better than nothing, and that's all we're gonna do because I'm kind of done messing with it. Hopefully this thing is acceptably balanced because I'm kind of getting done. All right, let's get vertical again. Go forward. little bit. Let's fix that. Sweet. And then let's give our air brake a kick. If I'm working on the tools to do something and I want to rotate the spider to get the tool in a different position. So like, I would never take this tool apart in this position. The way I take this side piece off, I have it like this and rotate it down so that my hands reach the handles perfectly. Let me just go ahead and call this it. But what I need to do is set myself a reminder to change the date dial. So we'll take one of last year's date dials. I'm going to put it in my notebook. So maybe that will remind me to take the tool apart. It's like I actually have to take that mold all the way apart in order to change its date dial to point to 8 of 22. I think it's pointing to 6 or 7 of 22. So anyhow, that ends up, that's my favorite part of most of the work I do on this rotational machine now is getting the arm pretty well balanced. It's just fun and challenging and rewarding, and it usually doesn't take too long. So let's run it for a minute and see if it's less noisy. So let the air on. Much more quiet. That's a lot better. Plus, you know you're off balance when the chain starts bouncing and you'll hear an unevenness with the whine of the motor. So like I said, the only reason I have this exact setup easy to do so quickly is because I've done this exact setup so many times. Like literally, this is our normal production mode right here. So thanks so much for watching. I hope it was entertaining. If you have any questions, please comment. I'll see your comments and I'll help answer. Or if it's a great enough question, I will make a whole video to explain it. I don't mind explaining things. It helps me better learn something in order to explain it to somebody else. So I really enjoy when I get to share and then I grow as a person. Don't forget to like and subscribe and hit the bell. I go live Eastern time, say somewhere between 11 a.m. and 5 p.m. Say somewhere between 11 a.m. and 5 p.m. normally is when I'm absolutely welcome to tune in, say hey, or just have it in the background, whatever, it's fine. There will definitely be lots of videos about the rotational molding machine. I intend to cover each system separately, as well as giving a great overarching big story of how it works and the process and why and all that. But there's so much knowledge I've learned. We went and got this machine. It had been disassembled and more or less abandoned in a parking lot. Got it in through here and I put it together. I rewired it. I routed the gas. We had an HVAC contractor confirm my work. I told him what I did and he's like, cool, I'll sign off on the permit. I ran the air system, completely rebuilding that and rerouting everything. Most of the systems were located on top of the oven before, and now everything that does not have to be up there is located around the perimeter, so I can get to it and do better maintenance or inspection. Um, when you have a high production facility, the management put everything on top so workers couldn't mess with things or change values. Different philosophies. Anyhow, thanks so much. I appreciate you watching, and I always enjoy feedback and commentary. So we'll hit end stream, and then we'll have to end again. Thanks, y'all. Bye.